Okay, we're now looking at some examples with projectile motion. First question here, it says find the horizontal and vertical components of the velocity of a projectile moving with speed 12 metres per second at an angle of inclination of 60 degrees. The other one says minus 60. Now, when you want to do the horizontal and vertical components of velocity, that's the right angle triangle that you draw up. Okay, so we draw the right angle triangle for velocity. That's your velocity 12 metres per second at that angle. Down here we've got x with a dot on top, so that's the horizontal component of the velocity, x with a dot on top. And here we've got a y with a dot on top, that's the vertical component of the velocity. So remembering, before we do that, doesn't cos of 60 equal what? What's cos of 60? I know that, but what's cos of 60 equal to? X dot on 12, so we're missing a line here, sorry. Cos of 60 is x dot on 12, are you okay? Therefore, x dot equals 12 cos 60, do you see that? Which is 12 times a half, which is 24 metres per second. So the horizontal component of the velocity is 24 metres. And thank you very much, it is 6. I was thinking 24 was a bit big. And see, before you write y dot is 12 sine 60, we should be writing sine of 60 is y dot on 12. Sine of 60 is y dot on 12, therefore y dot is 12 sine 60. What's sine of 60? Root 3 on 2. So therefore this is 6 root 3. That's the vertical component of the initial velocity. Now the next question.
Yes.
Yeah.
On the side you're writing like sine
because
60.
that should have been up there.
Oh, okay.
That should have been up there, sorry. These are someone else's worksheets that I'm just using. Look, unless you can remember that x dot is v cos 60, v sine 60. But if you can't, you just do your right angle triangle. Cos of 60 is x dot on 12. So girls, that's velocity. This has to be horizontal velocity, vertical component of velocity. The three velocities in the triangle. Now, it says if the angle of inclination is, with the next one, negative 60. You know negative 60 is down here. If that's the x-axis, if that's the y-axis, negative 60 is travelling in the negative direction, which is clockwise. So, just asking the same thing, we want the horizontal and vertical components of the velocity if the angle of inclination is negative 60. I don't know how we would have a projectile. That would only be when you're hitting the ground. You might have an angle like that if you were hitting the ground. But I normally wouldn't ask this question, but we'll just do it anyway. So that means that that's x and this is y if the angle is negative 60, because you've got to come down from here. You okay with that, girls? So if I went down like this, now if that's my velocity, it's still 12. This would be y dot, this is x dot, okay? So that's that triangle there. X dot, y dot. Again, cos of 60 is x dot on 12, therefore x dot is 12 cos. Sorry, girls, what does cos, I'm very sorry, over here. I'm going to do it over here. Cos of negative 60 is x dot on, actually, if we're working in the triangle, all right, negative answer for this y dot, okay? So the girls, if the particle is going down, if it's travelling downwards, it's still going across to the right, which is positive. You know, right is positive, left is negative, down is negative, up is positive. If a particle's going this way, it's going to the right and down. That's its position, like that's the way it's going. Going to the right is positive, but going down is the negative, so expect y dot here to be negative. All right, now, if we do our triangle again, sine of negative 60 is y dot on 12. Therefore, y dot is 12 times sine negative 60. We know that in quadrant 4, sine of negative 60 is the same as negative sine 60, so we put the negative at the front. Does that make sense? It's because sine of negative 60 equals negative sine 60. That's why, in quadrant 4. Okay, so therefore we've got negative 12 sine 60, which is negative 12 times root 3 on 2, which is negative 6 root 3. See, girls, if the velocity, if you've got a vertical velocity acting downwards, going down, so if I've got the arrow going down, you're going across and you're going down. That particle's moving to the right and downwards. Moving to the right, you should get a positive answer for the horizontal component of velocity, but you should get a negative answer for the vertical component of the velocity because it's going down. Okay? All right. The time when you'll use that is when we're going to be working out impact angles. When a projectile takes off and it hits the ground, we might ask you for the angle at which it hits the ground and stuff like that. So the horizontal velocity will be positive, but the vertical component of velocity there will be a negative. All right, but you'll see that when we do questions. All right, let's look at the next one. Now, the next question says, find the speed v and angle of inclination theta to the nearest degree for a projectile for which x dot is 4 meters per second and y dot is 3 meters per second. So girls, x dot, y dot, horizontal component of velocity, vertical component of velocity. We draw the right angle triangle for velocity with a right angle here. X dot is 4, y dot is 3. This is Pythagoras' theorem. Okay? Tell me what v is. 3, 4, what? 5. V squared is x dot squared plus y dot squared, isn't it? So v squared will be 25, so therefore the velocity is the square root of 25, which is 5. But if you look at the angle will be tan theta. Tan theta is 3 on 4, so therefore that angle of inclination is tan to the minus 1 of 3/4, which is 37 degrees if you were to do it. So girls, if you're given a horizontal and a vertical component of velocity, you can use Pythagoras' theorem to work out the actual velocity, and you can use trigonometry in your triangle to work out the angle at which the ball was fired. Now, girls, this particle here would be hitting the ground. It's on its way down to hit the ground, okay? So, horizontal component of velocity is 5, so that's going to the right. Vertical component of velocity is negative 2, so that's going down, all right? So 5 means to the right. Negative 2 means down. So therefore, v squared is 5 squared plus negative 2 squared, which is 29, square root of 29, whatever that is. 5 point something. Tan of theta is negative 2 on 5, and you'll get negative 22 degrees, meaning a negative angle means it's measured clockwise from the horizontal, from the positive x-axis. So that angle down there is negative 22. It just means it's 22 going downwards. Okay? Look, so if that's 22 there, let's say I had the ground here, and if that's 22, this down here would be 22. Do you see that? Alternate. So the angle at which it hits the ground would be at 22 degrees if it was hitting the ground. But we'll be doing questions like that later, all right? So it says theta is acute. It's got to be between negative 90 and 90, okay? All right, now let's look at some of these. Let's hope these are a bit more normal. This is like what I was going to do over the... And it just says here with theta, if theta is positive, it's travelling upwards. If theta is negative, the ball's travelling downwards, or the particle's travelling downwards. Okay? Because the angle is always measured from the horizontal. Just like in trig, when we measure angles, it's always from the positive x-axis. You know, positive angle, negative angle. Remember that? All right, let's look at question 3. Are we ready? It says, a ball is thrown with initial velocity 40. That means that that's 40. At an angle of inclination of 30 degrees. From the top of a stand, which is 25 meters high. So girls, initial position is not 0, 0. Initial position is 0, what? 25. Good. That's position, that's x. But we always start with acceleration, remember. From last lesson, we always start with acceleration. So this is where the particle starts from. Velocity of 40 meters per second, angle of inclination is 30 degrees. It's always inclined from the horizontal. Okay, Let's look at, it says using the top of the stand as the origin and g equals 10 meters per second, find the 6 equations of motion. 6 of them, meaning we want horizontal acceleration, velocity, displacement, and we want vertical acceleration, velocity, displacement. They're actually taking, okay, so you always start with horizontal motion. Remember, the only force acting on this particle is gravity downwards. So horizontally, acceleration, there is no air resistance. We're ignoring air resistance and everything like that. So horizontally, acceleration is 0. Therefore, x dot is, do you remember, the integral of 0 dt, which is c. We'll call it c1. Now, let's look at our original equations. Remember, x dot is velocity. So you draw an original velocity triangle, and what do we have? 30 degrees, 40 meters per second, x dot, y dot, here we go. Don't we go sine 30 is y dot on 40, therefore y dot is 40 times sine 30. You know what we're doing? Which is 20. So initial, girls, you only draw this triangle for velocities, only for velocity. Cos 30 is x dot on 40, so x dot is 40 cos 30, which is 20 root 3. We okay with that? Initial velocity triangle. Initial velocities. So therefore, coming back over here, you got that? We've got, initially, when t is 0, the horizontal component of velocity, as we saw from here, is 20 root 3. Therefore, the constant one is 20 root 3. So therefore, x dot is 20 root 3. Remember that? So x, therefore, horizontal velocity is 20 root 3. Remember, x is the integral of 20 root 3 dt, which is what? So we've got x dot is 20 root 3. X is the integral of 20 root 3 dt, which is 20 root 3t plus c2. So when time is 0, x is 0. So therefore c2 is what? So let me just do it down here. X is 20 root 3 times 0 plus c2. So that's 0. What does c2 equal? 0. Therefore c2 is 0. Therefore, x is 20 root 3t. Because we've got x is 20 root 3t plus c2. Next time I won't write the integral. I think this is really, let me just fix that. So I'm fixing this because there's no room. So therefore, if the horizontal x dot is 20 root 3, then x is 20 root 3t plus c2. Is that better? Because you're integrating. Got it? So when t is 0, x is 0, therefore c2 is 0, therefore x equals 20 root 3t. Got it? Yeah? Yes. All right, there are 6 equations. Here come the other 3 equations. Right. Remember we've got that triangle. Remember we had the triangle and all that? So, particle was here, it took off here, we had that. What was this angle? 30? This was 40? Was it 40? And this is 25. And there's the particle. It takes off from there. Okay, x dot, y dot. Okay, vertical components of the velocity. So we start with acceleration always. Acceleration is negative 10. Y dot is the integral of negative 10, which is what? Negative 10t plus c3. When t is 0, what does y dot equal? Doesn't sine of the, yeah. So didn't we had that it was 30, what was it? It was 40 sine 30, wasn't it? Which is, go and look back at the other part. It was 40 sine 30, which was 20. So when t is 0, the first initial right angle triangle is for initial velocities. You know, from here, sine 30 is y on 40, therefore y dot on 40, therefore y dot is 40 sine 30, which is 20.
So is that how you always work out?
Yes, always you work out horizontal and vertical. You use the triangle for velocity, initial velocity. Use the triangle for initial velocity. So therefore, what does C3 equal? When t is 0, y dot is 20. Oh, I wish I had some room. So 20 is 0 plus C3. What does C3 equal?
20.
You'll get 20 when you substitute it into here. 20 equals negative 10 times 0 plus C3. So that's the working out. So therefore, C3 is 20, so therefore y dot is negative 10t plus 20. So girls, I don't want to take where it left as the origin. I'm going to say that when time, so what's y anyway? Negative 10t squared on 2 plus 20t plus C4. Now girls, I know they're saying take where it leaves as the origin, but I don't want to. When t is 0, what's the y value?
25.
I want to put it as 25. So therefore, if you put t is 0, y is 25, what do you get for C4?
25.
So therefore, y is negative 5t squared, because negative 10t squared on 2 is negative 5t squared, plus 20t plus 25. Please do not take where it left as the origin, because when you start answering other questions later, if they tell you to take it as the origin, you have to. It's just that if you're answering other questions later and you take it as the origin, you're going to have to go into the negatives when it hits the ground, and I'd rather not do that. I'd rather put the particle where it is. All right?
Why don't they just let it take out of the time?
T's for time. The question is, find how high the ball will rise and how long it takes to get there, and what is its speed then, and how far is it horizontally from the stand. Now girls, how high will the ball rise? What has to be a maximum? Y has to be a maximum. You know, because the particle goes like this, girls. We want y to be a maximum. That's so when y is a maximum, y dot is 0. So y dot is negative 10t plus 20. We've got it over there. Y dot is negative 10t plus 20. So negative 10t plus 20 is 0. Therefore, t is, you can see it already, 2. So therefore, this maximum occurs when time is 2. So now when t is 2, what is y?
Minus 10 times 2.
Well, the formula is minus 5 times t squared, which is 4, plus 20 times 2, which is 40, plus 25. Are you okay with that? I'm putting it into the y equation, minus 5t squared plus 20t plus 25.
Why not get y dot equals 0?
Because when you want to, if I say find maximum area, don't you do dAd whatever is 0?
Oh yeah.
So the first derivative, for maxima or minima, first derivative equals 0. That's what we're doing.
So I just have t equals 2.
So now I substitute t equals 2 into the y equation. So I've worked out the time when I'll get maximum y. So girls, this is now the y-x graph. This is the y-x graph. At time equals 2, we've got the maximum value of y. So we substitute t equals 2 into the y equation. It's negative 5 times 2 squared if you want. Sorry? No. All right, I'll fix it. I just put 4 because 2 squared is 4. Negative 5 times 2 squared. Is that better? Negative 5t squared. So which is negative 5 times 4. That's negative 20 plus 40 is 20. Plus 25 is 45 metres. So that's the maximum height. Now, it says, find how high the ball will rise. We did that, 45. Well, actually, girls, okay, it'll end up at 45. Actually, no. How high will the ball rise, by the way? It only rises 20 metres because I took this. How high does the ball rise, girls? From there to there? Because it's gone from 25 to 45. So how high does the ball rise? Therefore, ball rises, how high? 45 minus 25, which is 20 metres. It does get to a height of 45 metres above the ground. Do you get what I'm saying? Read it carefully. How high will the ball rise? It started at a height of 25. It ends up at a height of 45. It does rise 20 metres. All right? Now, the reason, that's why they took the ground where it takes off as 0, but I didn't put where it takes off as the origin. I've put where it takes off as where it takes off, okay? So, it says how high the ball rises 20 metres to 45 metres. Does that make sense? How long does it take to get there? 2 seconds. And what its speed is then, and how far it is horizontally from the stand. Well, we can work out the horizontal bit easily. Know its speed then. Actually, you tell me what its speed then is. We do know. Well, it should be, yeah. Oh, wait a sec, no. Yeah. Only the minute. So, it says how far is it horizontally from the stand? Do we know what to do there? When t is 2, what's the equation for x? 20 root 3 times 2, which is 40 root 3. So that, I shouldn't put 2 there because that's not 2, that's time is 2. That's 40 root 3 on my diagram. Got it? I shouldn't put t there, this is a y-x graph. That is 40 root 3. So it takes 2 seconds to reach the top. And then we substituted t is 2 into y to get how high it is, but it's actually only travelled up 20 metres. And we substituted t equals 2 into the x equation to get its horizontal position. Now, it says work out its velocity at that time. Now, girls, there's always a horizontal and vertical component of the velocity. So you need to go to the equations for y dot and x dot. Now, at this very point, we know that y dot is 0. So this is 0. Girls, go back and look at the x dot equation, and it's a constant. It's a constant. Can you look back at the x dot equation, please? What is it? 20 root 3. In other words, girls, the horizontal velocity is 20 root 3 regardless of where that ball is. It's always 20 root 3. You know what? If the horizontal velocity was 0 at that time, it would actually not travel to the right anymore. It wouldn't. Why do you think the particle is going to come back down? Because the vertical velocity is 0. There's no more upward velocity, and that's why the particle's about to come back down. But girls, the particle is still going to travel to the right from this point onwards. So the horizontal component of the velocity is a constant, so it's always 20 root 3. The initial horizontal component of the velocity was 20 root 3, but because there's no t in it, it's a constant 20 root 3 no matter where you are. So 20 root 3 and 0, that's what we've got, horizontal and vertical. So therefore the velocity is 20 root 3 squared plus 0 squared. Girls, that's not right. That hasn't been fixed. What's the answer? That's a mistake. What is it? 20 times what? 20 times, what's that? Oh, then you've got to square root it. It's right. What do you get? Girls, what do you get? If I go v squared is 20 root 3 squared, what's v? 20 root 3. Girls, v squared is 0 squared plus 20 root 3 squared. So v squared is that squared. Keep it as squared. So v is the square root of that. Just get rid of the squared sign. It's 20 root 3. Does that make sense? Sorry, I thought there was a mistake. I think the sooner we do our own questions, the better. I don't like using the sheet. All right. I don't like it. I might just do the questions myself instead of filling in the sheet. Are we ready? Time of flight, girls. What are you going to do? Are we okay? Time of flight, girls. What is the only thing about time of flight that you know? How are you going to tell me how long it takes? Girls, time of flight. Stop. Yeah? No. Yeah, only if you use the origin. You did? Well, I didn't. So we didn't use the origin. How do I work out the time of flight? Oh, no. Our equation for y? Negative. What's our equation for y? Negative 5t squared plus 20t plus 25. Now, when will this particle hit the ground? When y equals 0. So we put that equal to 0. So there's our equation for y equals 0. Negative 5t squared plus 20t plus 25 is 0. Now just take everything over to the other side and you get that. All right? Can you fix that, please? So now dividing by 5, you good with that? And factorising t minus 5t plus 1. Therefore, t equals 5 or t is negative 1. Girls, you know where the negative 1 is from? Have a guess. That's 5 seconds. If I continued that, can you see? That would be the negative 1 there. All right? So, but we know that time is positive, all right? So t is greater than or equal to 0, therefore t equals 5. So, when t is 5, girls, you can work out the horizontal position now. So the time of flight is 5 seconds. How far did it travel? Well, when time is 5, substitute that into x. Doesn't x equal 20 root 3 times t? So that's 100 root 3. So when time is 5, x is 100 root 3. So find the flight time, which we've done. Find the horizontal range. We've done that. It travels 100 root 3. Find the impact speed and the angle. Now, impact speed and the angle all has to do with the right angle triangle. Girls, look how the ball's hitting the ground, like this. So velocity's coming down, right angle triangle. Now, girls, always, you could do the right angle triangle like that too if you want. If I just do it dotted like this as well. See, you know how the ball, look what the ball does, girls. It goes across and down, across and down, across and down. Remember how we said the 20 root 3 is constant? That's the x dot. And the y dot will have a value here, but we're just trying to work out what it is. Now, that is the same as doing the triangle. I can do the triangle like this, or I can do the triangle like that. It doesn't matter. Do you get it? Because I like to do it like that, because can you see the particles going across, down, across, down, across, down? So if you do that, these will be the same. If that's 20 root 3, that will be 20 root 3. Whatever you get here, you'll get the same there. Now, this one has to be negative, because look, across to the right is positive, down is negative. Across to the right, down is negative. Is 5. Go back to the formulas for x dot. Isn't x dot a constant? 20 root 3. When t is 5, the formula for y dot is what? Negative 10t plus 20. So it's negative 10 times 5 plus 20, which is what? Negative 50 plus 20 is negative 30. So we'll put that on the diagram. It doesn't matter. Why do you think, Miss, the triangle's drawn this way? Because that, well, you could do it two ways. If I do it this way, I can work out that angle up there or this one here, but we want the angle at which it hits the ground. So see how this angle here, alpha, is the angle at which it hits the ground? So instead of drawing it up there, you can draw the triangle down here. 20 root 3, negative 30. It'll be the same numbers, but you'll automatically get that angle. If you work out this angle up here where I'm pointing, you've got to do 90 minus that to give the alpha. All right? So girls, those two triangles are identical. If you want the angle where it hits the ground, girls, just watch what I'm going to do. You know, I like to go across, down, but we can go like this. Watch. Down, across. Where's down, across? So that's how Miss is doing it like that. Probably better this way because you get that impact angle, the angle at which, here's the ground, the angle at which the ball hits the ground. So let's go. V squared is negative 30 squared plus 20 root 3 squared, which is what? Isn't that 900 plus 6 for 1200? Is it 2100? Square root of 2100?
Yeah.
What's that?
It's 10 root 21.
Is it square root of 2100? I got 900 plus,
Yeah.
I don't know what that equals. 10 root 21? 10 root 21, that's the impact speed. And tan of alpha, girls, is negative 30 over 20 root 3, and just do it on your, look girls, hello, the angle in here, the reason you've got negative, you are sitting, you'll be doing quadrant 4, okay, and that's why you're going to get negative. But just to purely work out the angle, I wouldn't put the negative in, all right? I'll just go tan alpha is 30 on that. The size of that actual angle can't be a negative answer. It's got to be positive, which is 41 degrees, okay? So girls, impact angles, velocity triangle. The only thing that relates alpha with velocity is the velocity triangle. So if you ask for impact speed, impact angle, velocity triangle, all right? So can you put a note, must use velocity triangle for impact speeds, impact angles, all right? Now, next one. I've got a whole lot of sheets with questions. We're going to do them after this. All right, let's have a look. All right. A gun fires a shell with initial speed of 200 meters per second at a variable angle of inclination. So we don't know the angle of inclination. Taking g, the acceleration due to gravity, as 10 meters per second. Of course, that acts in a downwards direction. It says find 2 possible angles at which the gun can be set so that it will hit a fortress a fortress F 2 kilometers away on top of a mountain that is 1,000 meters high. Now, look, this is what's going to happen. So, girls, the ball is either, if this is the fortress, it's 1,000 meters high, it's 2 kilometers or 2,000 meters away. Are we listening, girls? The only way that that ball or gun, whatever it is going to hit the fortress, it's going to hit it on the way up, girls, or ladies. So girls, we can hit it on the way up or it can hit it on the way down. So we're looking at 2 different angles of alpha, this angle or that angle there, okay? Well, how can you hit a target over there? Either it's going to hit it on the way up or it's going to hit it on the... So girls, if I shoot the thing like that, it can either go like that, I can hit the target. You don't get that, what I'm doing? Girls, all right, we're shooting something with a gun from here. We're trying to hit this target here. You're either going to hit it on the way up or you're going to hit it on the way down, okay? They're the 2 possible angles. So, it says, find 2 possible angles at which the gun can be set so that it will hit the fortress 2 kilometers away on top of a mountain, okay? And then it says, all right, let's look at the first one. So, let's just look at our equations of motion. Remember, we don't know the original angle. So, we've got horizontal acceleration is 0. Horizontal acceleration is 0. Remember, horizontal velocity is the integral of 0, which is a constant. So we know when t is 0, let's draw our initial triangle. When t is 0, what have we got? Sine of alpha is y dot on 200. Therefore, y dot is 200 sine alpha. These are our initial velocities. You have to always do this, initial velocity. Cos of alpha is x dot on 200. Therefore, x dot is 200 cos alpha. So, coming back over here. So, we always do those original triangles. Original acceleration horizontally is 0. Original horizontal velocity is a constant because yes, you always start with that horizontal because there is only acceleration in, and then you always start vertically. So that's how you derive the equations. You must always start with horizontal acceleration is 0. Velocity triangles, always have to draw them for initial horizontal and initial vertical velocity. Girls, if you look at that, x dot is 200 cos alpha, y dot is 200 sine alpha. Neither of those velocities anyway, will change depending on what alpha is. Okay, it just depends on what alpha is. So let's look over here. Horizontal acceleration is 0. X dot is the integral of 0, which is a constant. When t is 0, x dot is 200 cos alpha. Therefore, x dot is 200 cos alpha. Oh, sorry, girls. I don't mean to write that. So therefore, isn't it C1 is 0? Is that right? When t is 0, x dot... No. C1, it's right, isn't it? 200... Oh, wait a sec. So therefore, C1 is that... Therefore, x dot is that, is 200 cos alpha. X is the integral of that, which is what? 200 cos alpha t. Girls, because we're integrating with respect to t, all right, plus C2. When t is 0, initial position, where are we? When t is 0, x is 0, so therefore what's C2? So 0, 0, therefore C2 is 0. Therefore x is 200 cos alpha t. So that's horizontal. We've got one equation, we've got two equations, we've got three equations of motion. All right? The three equations of motion. Now we do the same thing vertically. Vertically, acceleration due to gravity is -10 because it acts downwards. Y dot is what? -10 t plus c3. Now, when t is 0, looking over at your velocity triangle, y dot is 200 sine alpha. So when t is 0, y dot is 200 sine alpha. So if you put t is 0 there and y dot is 200 sine alpha, what does c3 equal? 200 sine alpha. So therefore y dot is -10t plus 200 sine alpha. What does y equal? So we've got one equation, two equations. Don't we integrate again? And what do you get? -10t squared on 2, which is -5t squared, plus 200 sine alpha t plus constant 4. Now, initially, when t is 0, y is 0. It starts from the ground. When t is 0, y is 0. So I've got 0 there, there, and there. So what do you get for C4? So therefore, y is -5t squared plus 200 sine alpha t. Now, the only time you'll get a different value for C4 there is if your particle's not starting from the ground. So we've got our 6 equations of motion. Now, we still haven't found the angle. Now, it says, are we okay? So we've got our 6 equations. It says find 2 possible angles at which the gun can be set so that it will hit a fortress 2 kilometers away on top of a mountain 1,000 meters high. So the only thing that you know is that when x is 2,000, you want y to be 1,000, yes? So what we're going to do, girls, this is what we need. We require that when x is 2,000, that y is 1,000. So we can work out that time by substituting 2,000 into the equation for x. Now we know that x equals 200 cos alpha t. So if you put x is 2,000 in here, we'll work out what the time is, and then we can substitute that into the time equation, into the y equation, sorry.
You're making a Cartesian equation.
Yeah, I think we should make a Cartesian equation. Yeah. So what have we got? Yeah, because that will eliminate, yeah, so we're going to make t the subject. So when x is 2,000, y is 1,000. So we've got 200t cos alpha equals 2,000. So therefore t is what? 2,000 over 200 cos alpha, which is what? 10 over cos alpha. So we're now going to substitute that into the equation for y, but we put that y is 1,000 as well. So we've got y equals negative 5t squared plus 200 sine alpha t. So we know that we want when y is 1,000, so we put 1,000 in there and we get negative 5t squared plus 200 sine alpha t equals 1,000. Now we know that the particular time we want is here. Time is 10 over cos alpha. Does this make sense? So we go 10 over cos alpha squared. 10 over cos alpha. So we've got negative 5t squared. Girls, instead of putting the squared here, can I fix exactly what it is? What would I write?
Like the inside.
Yeah, now what would it be?
100.
100 over cos squared alpha. Is that okay that I do it straight up? Negative 5t squared plus 200t sine alpha, bringing the 1,000 over here, minus 1,000 equals 0. We then end up with, oh, I really wish I'd do my own. We then end up with, girls, what's negative 5 times, first, we're going to insert a line. Can I put it that it's going to go there? Girls, so the next line, she's missing a line. It will be negative 500 over cos squared alpha plus 2,000 over sine alpha, 2,000 sine alpha over cos alpha minus 1,000 equals 0. So we're missing a line in between. We've got negative 500 over cos squared alpha plus 2,000 sine alpha on cos alpha minus 1,000 equals 0. Now we're going to divide through by 500 because, yeah, negative 500 actually. So dividing by negative 500, we get, well, the 500 goes. You get 1 on cos squared alpha. Sine alpha on cos alpha is tan alpha. 200 divided by negative 500, 2,000 divided by negative 500 is negative 4 tan alpha. And negative 1,000 divided by negative 500 is positive 2. Why do you think we're dividing by a negative? Because the squared term is negative. Negative. See, I've got negative 500 cos squared alpha. I've got sine alpha on cos alpha is tan alpha. But girls, remember, just coming back here, we don't want the squared term to be negative. That's why we're dividing by negative 500. If you don't want to divide by negative 500, that's fine. Just take everything to the other side. All right? So girls, what's 1 on cos squared alpha? Isn't it sec squared alpha? Minus 4 tan alpha plus 2 is 0. Isn't sec, it's 1 plus tan squared. Minus 4 tan alpha plus 2 is 0. Expanding this, we get 1 plus tan squared minus 4 tan alpha plus 2. The 1 plus the 2 makes 3 here. And now we've got a quadratic equation. So pretend that the tan alpha is an x. And can you factorize? Two numbers that multiply to give positive 3 but add up to give negative 4. Isn't it minus 3 minus 1? So therefore tan alpha is what? 1 or 3. So now tan of what is 1? 45 or shift tan 3.
71 degrees and 34 seconds.
71, no, degrees, minutes, seconds. 71 degrees, 34 minutes. So girls, if you go at 45 degrees, you're hitting the target on the way up. The lower one? Sorry. If you go at 45 degrees, you hit the target on the way up. If you go at 71 degrees, you hit the target on the way back down. Does that make sense? So if that's where we're leaving from, if you go smaller angle, you're going to go flatter. You're going to hit it on the way up. And if you go bigger angle, that's the 71 degrees up there, you're going to hit the target on the way back down. So they're the two angles. So girls, when you've got the two angles that you've got to do, you've got to end up forming the Cartesian equation. The main thing with this is that you look at where you want to hit. And the main thing was that you will hit there when x is 2,000 and y is 1,000. You put that into your two equations for x, not for velocity. That's giving you displacements. When x is 2,000, y is 1,000. Put them in, rearrange your x equation because it's really easy to rearrange. Substitute it into the y equation. Come up with your alphas. You'll end up with a quadratic equation. And solving that, see, it tells you the two possible angles. Obviously, a quadratic equation with two solutions. All right? So with this type of question, it's putting in your x, y value and finding the Cartesian equation. All right? If you ever asked for those angle type questions like that.
This is Cartesian without x and y.
Cartesian is, yeah, there's no x's and y's anymore. Well, normally it's just with y and x and no t's. Yeah, it's normally, but look, it will have the y and the x, but we've substituted. So the Cartesian is, it's like parametric equations. There's no t anymore. We make t the subject and substitute. There's no x and y's because we replace the x and y with values. All right? All right, we'll practice more of those, don't worry. So now, next question, it says, show that the two angles are equally inclined to OF. O is the position of the gun to the vertical. It is. Here's your original angle. That is O, that is F. Girls, there's OF. Can you see it? F was the top of the fortress. O is where you're starting from. OF is that. So girls, we know that. Let's just work out this angle here. Girls, how do you work out this angle here in there? All right, it's saying, all right, I'll show you what it's saying. So girls, down here, there's OF. You know how one angle was 71 and the other one was 45? Oh, that's really badly drawn. I'll have to do it on the board. Oh, here. OF, is it 1,000 up, 2,000 down? Girls, this sounds a bit... If it was 2,000 across, 2,000 up, that would be a 45-degree angle. Do you get it? Do you agree? One of our angles was 45, wasn't it? And the other one was 71. And OF is down here because it's 2,000, 1,000. This is the weirdest question. Oh, sorry. There's OF. There's, no, it's not. That's the 45-degree angle, right? There's OF. All right, let's work out the angle for OF. What is it, girls? OF, isn't it 2,000 across, 1,000 up? I'll just put an angle. Isn't tan of theta 1,000 over 2,000? Which is a half. So what's tan to the minus 1 of a half? Angle, why have they got OFX? I think it's the other way around. It shouldn't be that. It should be FOX. Angle FOX. Angle Fox. So, angle FOX, isn't it tan of 2,000 is tan of theta is 1,000 over 2,000. What's shift tan of a half?
26 degrees and 34 minutes.
26 degrees, 34 minutes. So they're saying 45 minus that. I don't know what they're talking about here.
5 minus that is 18 degrees and 20.
So 45 minus 26 degrees, 34 minutes is what? 18 degrees, 26 minutes. And then, so the angle from that to the 45 and then this angle. Oh.
What are they asking for?
No. What they've got, all right, look, I wouldn't worry too much about this. I don't think I've seen a question like it. There's your OF. This angle is, I wouldn't worry about it. This angle is 26 degrees, 34 minutes. They're saying it's 18 degrees, 26 minutes from that centre line, right? Which is 45. And they're saying also that from the 90-degree angle, the 71-degree, 34, that angle in there is also 18 degrees, 26 minutes. Look, I haven't seen a question like it. So, yeah, it's a bit of a Don't worry about it. No, I don't. It's just showing that last one will be important. Find the corresponding flight times and the impact speeds. Find the flight times and the impact speeds. Okay. That at time equal to 10 over cos alpha, that the shell will hit the top of the fortress. Yes? Yeah? You know how we got that value? T equals 10 over cos alpha, and then we substituted that in to the y equation and all that? So when at time equals 10 over cos alpha, the shell hits the top of the fortress. We want the impact speed. So we've got two scenarios. When alpha is 45 degrees, you know, and we've also got when alpha is, what was the other one? 71 degrees, 34 minutes. Remember we got the two values for alpha? So when alpha is 45 degrees, T is 10 over cos 45, which is 10 over root 2. Okay, now we can substitute that. If we want the impact speed, that's got to go into the velocity equations. But there are two velocity equations you've got to put it into.
Wait, isn't it 10 versus 1? Yeah.
Sorry. 10 divided by 1 on root 2, which is 10 root 2. So when the time is 10 root 2, we can work out x dot and y dot. Now the formula for x dot is 200, why did I even bother? Cos alpha, actually I don't need it, do I? I didn't need to do that.
Why?
Because where am I going to put it into? Well, x dot, oh, I might need it. I think I'll need it for the y dot. So I can look at the formula here. X dot is 200 cos alpha, which is 200 cos 45, which is 200 over root 2. We've also got that y dot. Girls, I'm just putting it into x dot and y dot. Y dot is it? Yeah, no, y dot is minus 10. Now I'll use it. Minus 10t plus 200 sine alpha, which is minus 10 times 10 root 2 plus 200 sine 45. Are we okay? See, girls, if you want to work out an impact speed, an impact angle, you need, whenever you're doing anything with speed, you need both the vertical and the horizontal components. Now, I'm doing, you know how we said it's going to hit it on the way up? I'm doing it on the way up, the triangle, it looks like that. But on the way down, the triangle's coming down the other way. On the way down, I've got my triangle going the other way. All right? So y dot is negative 10t plus that. Putting in what the t is and the alpha, I get negative 100 root 2 plus 200 over root 2. What do you get there? That's 200 root 2 over 2, isn't it? Girls, that's negative 100 root 2 plus, how do you rationalise this? Times root 2 over root 2, which is 200 root 2 on 2, which is? No, it's 200 root 2 on 2, which is 100 root 2, which is 0. That means that must be the top. It must actually then come back. That must be the exact top.
So he's right exactly on top.
71 degrees, 34 minutes. X dot is 200 cos 71 degrees, 34 minutes. Y dot is negative 10 times, is it the same time? Is it 10 root 2? Yeah. Negative 10 times 10 root 2 plus 200 sine 71 degrees, 34 minutes. I just want to see what we get here. All right? Oh, no, it is 10 root 2 because we put 10 root 2 in and we got the 2 times. Remember? Yeah, look. When we put 10 root 2, 10 over cos alpha. Oh, no, it's not. No, 10 root 2. Thank you. Thank you, thank you. Good girl. Good girl. So it's 10 over, I'm so sorry, thank you, cos 71 degrees, 34 minutes. Yeah. So it's negative 10 times 10 over cos 71 degrees, 34 minutes, plus 200 sine. Thank you, Lydia. So we can get our x dot and our y dot. This is for when the, you know, if it takes the high road and it comes down and hits like that. I'm thinking we might get that 63-degree angle here.
Can we draw the other triangle? You get 20.
Yeah, you can. You can do the triangle down here, it doesn't matter. All right, it's just that that's coming on the way down and hitting, which is why I like to draw it like that, or you can draw it down here, either one.
So the other one you said to draw it like
Yeah,
that.
you can do it either way.
So it doesn't matter.
It doesn't matter.
For x dot, it's 20 root 10.
Exactly.
X dot, yeah.
20 root
10.
for cos 71 degrees, 34 minutes.
It is. No, not for y.
Oh, yeah, because it's a constant, isn't
Yeah,
it?
for x.
I'm so sorry. Really? For cos 71 degrees, 34 minutes? Okay. You sure?
Someone else check. Yeah, me, it's sure. 63.2. Yeah, and then if you square that, you get the square root of 4,000. Look, you go, if you do 200 cos. No, I have it saved already. Wait. I did the full
Oh,
one.
yeah, you put the full one, yeah. She's got the one that hasn't been rounded.
So I did
200.
200 cos, and I did that, which was
Yep.
the answer. And then if you square that, you get that.
All right.
And then you can, do you know what yeah.
Square root of that. All right. Look, I don't mind what you put. Najashri kept the exact answer. Remember, this is rounded off. So she's kept the exact angle in her calculator. And she got that it was 20 root 10. But it is the square root of 4,000. All right? But, or it's 63 point. Has anyone just worked it out to decimal places? It'll probably work out. So it's 63.2 what? No. I thought it was 26 something.
24555.
Has anyone put it in? And then the y dot, has anyone put that in? Negative 100 over cos 71 degrees 34 minutes plus 200 sine 71 degrees 34 minutes. Has anyone done it?
400. I know this one.
That? Anyone? Negative 100 over cos 71 degrees 34 minutes plus 200 sine 71 degrees 34 minutes. Have you? You've got exact values, haven't you, Najashri?
You don't get exact values.
This is not in radians, is it?
No, they're degrees. They're degrees. You don't use
I
radians.
got 48.35.
Anyone else? 48.3, whatever.
Yeah.
What?
31530.
All right. Work out v using Pythag. Look, we're rounding off. We're not going to get an exact. Bit disastrous. And then you can work out an impact angle. Can someone work out the angle? Tan. So we definitely can't. Yeah, all right. We'll see.
It's like a negative 126 for y dot. Yeah, I got negative 126.5.
Oh, well, all right. With impact speed and angle, you need to work out, you need to know the time when it hits and the angle in this case as well. So we worked out when alpha was 71 degrees 34 minutes, we put it into the equation for horizontal velocity. Remember, horizontal velocity doesn't have a t component often. Well, it doesn't. But the vertical one will. Horizontal velocity is constant all the way through because there's no t in it. But it does depend on the angle at which you fired it. Vertical velocity changes all the time. Okay? It'll be up and then it'll be 0 and then it'll come back down and be negative, the vertical velocity. Because girls, if you do a series of steps, look, do a series of steps. Sorry, my steps aren't good. But girls, but if I just think of it as I go up but across the same amount every time, up across the same amount, up across the same amount, that horizontal See, these are all the different triangles I could draw for velocity on the way up. The horizontal one's always the same, so horizontal down. But here, there's no up or down when I hit that top. There'll be no vertical velocity, it'll be 0. Because it's positive velocity for y going up, 0 for y dot, sorry, and then y dot will be negative on the way down because the particle's travelling down. But always across, x dot's the same. All right? Now, when you need impact angles, impact speeds, it's that triangle. So impact speed is the triangle at that particular time when it hit the target. Okay? So it hit the target at 10 over cos alpha. So we put 10 over cos, hits it at 10 over cos 71 degrees 34 minutes when it's taking the high path. All right? At the point, yeah. You know how we could project the ball really high and it would hit on the way back down? That's this one. That's this one. See, if you, remember we could hit the ball two ways. Look, you could hit it like that. Now, according to getting y dot 0 here, it must have just touched it, I reckon. The first one at 45 just hits. And that is the very top of its path. And it would have come back down because we're getting y dot is 0 up there. It's like the maximum. Remember, y dot is 0 at the maximum. And then the other one is hitting on its way back down. So, we've got, this is for the one that's hitting on the way back down. We know that's at time 10 over cos 71 degrees 34 minutes. We work out the horizontal and the vertical components of velocity at that time and do Pythagoras' theorem and trigonometry. Pythagoras' theorem gives you the velocity. Trigonometry gives you the angle. All right? Look, we're going to practice it heaps more times, all right?